Section 9.5. Our objective today is I can solve problems involving inscribed angles and angles formed by chords and tangents. So first, an inscribed angle. What is it? It is an angle whose vertex is on the circle. And whose sides are chords of the circle. Okay? So if we have this circle and we have these two chords, and this is A, B, and C, then angle BAC is an inscribed angle because its vertex is on the circle and it is formed by two chords of the circle. Okay. Now our first theorem. The measure of an inscribed angle is equal to half the measure of its intercepted arc. Okay, so an example. So I have, right, so I know that this is 90, this is 80, this is Y, this is 55, and this is Z. Okay? And this is X, right? So this angle is an inscribed angle, so its measure is equal to half the intercepted arc. So this angle is 40 degrees, okay? And then we have this angle formed by those two chords, and its measure is 55 degrees. So that means its intercepted arc has to be twice that, or 110 degrees, okay? Then, if this is 110 and this is 90, so that's 200, and this is another 80, so that's 280. So that means this arc Z, has to be 80 degrees, okay? So that's how we would use that theorem. The next theorem says if two inscribed angles intercept the same arc, then the angles are congruent. Okay, and so an example of this is if I have this angle, angle A, and B, okay? And we know that arc AB equals 120, okay? So this arc is 120 degrees, okay? And so if this is angle 1 and this is angle 2, well, angle 1, angle 1 is formed by those two chords. Angle 2 is formed by those two chords, but they intercept the same arc. And so angle 1 must be congruent to angle 2. And angle 1 is equal to 1/2 120, or 60 degrees. So that means angle 2 must be 60 degrees also. Okay. Then we have some corollaries. An angle inscribed in a semicircle is a right angle. And again, that's a corollary, because if we have a circle, if we have this diameter, and then we have an angle inscribed in the semicircle, then those two chords intercept this arc. Well, that arc has measure of 180 degrees. And so then this angle has to be half the intercepted arc, so that has to be 90 degrees, okay? And then we have another corollary that says if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, so if we have a circle and we have some kind of quadrilateral inscribed in that circle, and let's say this is angle 4 and this is angle 5, and we know angle 4 is 75 degrees, then angle 5, this corollary says measure of angle 5 has to equal 180 minus 75, or in other words, they're supplementary, so it has to be 105, okay? And again, it just has to do with the fact that this is an inscribed angle which intercepts this arc, okay? And so this angle is equal to half that arc, so this has to be 150 degrees. And then this is an inscribed angle that intercepts this arc, and if that angle is 105, then that arc has to be 210, okay? And so then those two arcs added together equal 360, okay? And one more theorem. The measure of an angle formed by a chord and a tangent is equal to half the measure of the intercepted arc. Okay? And so that's something that looks like this. We have some circle, call it circle A. We have a point Z, and we have a chord y, x. And we have, x is also a point of tangency for line xp. Okay? And so we know that measure of arc x, z, y is 260. Okay? And so what we want to find is measure of arc xy and measure of angle pxy. Okay? So first of all, xzy is that arc. So it's 260. So that means that the other arc has to be 100. So this has to be 100. So measure of arc xy equals 100 degrees. Okay? Then angle pxy is an angle formed by a chord of the circle and a tangent to the circle. And the theorem said that that angle is equal to half the intercepted arc. The intercepted arc is xy, and so that angle has to measure 50 degrees.